So for us to be able to draw the graph for this, I don't even need 5 minutes. What I will do, I'll come to my constraints here. These constraints are the ones that you will come and give us their coordinates. How do you get their coordinates? You ask yourselves, when x1 is 0, what will be the value of x2? And when x2 is 0, what will be the value of x1? So when x1 is 0, what will be the value of x2? This being straight lines, of course, we need 2 points for us to be able to draw a straight line. For us to draw a straight line, how many points? 2 points. And how do we get the 2 points? Basically by fixing. You say when x1 is 0, what will be the value of x2? When x2 is 0, what will be the value of x1? Like that. Yeah, like Juliet, she's telling me that when x1 is 0, the value of x2 here will be 20. When x1 is 0, this disappears, then 5x2 will be equal to 100. So 100 divided by 5 gives me 20. How about when x2 is 0? What will be the value of x1? Somebody from equation number 1. When x2 is 0 here, when x2 is 0, then x1 will be 100 divided by 4, which will give me 20. What here? 25. Thank you very much. Now go to the second equation. Second equation, when x1 is 0. When x1 is 0, this disappears. Then we'll have 2x2 being equal to 80. Then x2 automatically will be what here? Somebody 40. x2 will be 40. Thank you very much. How about when x2 now is 0? When x2 is 0, x1 will be equal to what? When x2 is 0, x1 will be 80 divided by 5. 80 divided by 5, which gives us what figure? 16. Thank you very much. Now, ladies and gentlemen, having gotten that really, what we need now to do is to come and draw the graph. You draw the graph very fast. Come and draw the graph here. So come and draw the graph. So our graph will look like this. We have our first product. Always take the first product here. So we have x1 versus what here? x2 like that. x1 versus x2. x1 versus x2. Okay, so here we are, we have our points. So come and put up our points here. So I need about 10 boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Remember, the more the boxes you have, the better your scaling will be. So we start with 0 here. Now for x1, ladies and gentlemen, when you look at x1 very well, figures of x1, the very biggest figure of x1 that we are able to see here, x1, that you're able to see, I can see x1 of 25, I can see x1 there of 16. So the biggest figure of x1 that we have there is 25. 25, if you divide 25 by the 10 boxes, that's the general rule. If you divide 25 by 10 boxes, you will end up getting 2.5. 2.5 is not a good figure for scaling. If I'm the one doing this, I would rather go down and work with the 2 because I can't work with a scale of 3. So in this case here, we are talking of 2. So we have 2, 4, 6, 8. We have 10 there, 12. We have 14, 16, 18. So you have to proceed. The more the boxes, the better for you. We have 20, 22, 24, up 26. So you can count the 25, the highest there. Look at, ladies and gentlemen, x2. x2, I can see 20 there. x2, the highest figure of x2 is 40. So if you take 40 divided by 10, you will get 4. 4 is good for scaling purposes. So 4 is good for scaling purposes. 4 is good for scaling purposes. So we have 4, 8. So 4, 4, 4, right? 4, 8, 12, 16. We have 20, 24, 28, in this case here 32, 36, then we have got 40 like that. 40. Great. Now, ladies and gentlemen, if that is the case, what I'll need to do is to come and draw my points very fast. Look at what I will do is with constraint number 1. Constraint number 1, I can see x2 is 20. Where we have x2, come and mark 20 there. And then I can see x1 is 25. So 25 is in between 24 and 20. So mark there. So from there, come and join the 2. You join the 2 like that. So in this case here, draw using a straight line, a straight line, a straight line. And then, ladies and gentlemen, tell us the side to shade. Which side are we supposed to shade here, somebody? The upper side or the lower side? Remember, in linear programming, you must always shade some side. Which side are we supposed to shade? The upper or the lower? I can see a student saying here, the upper. The upper, thank you very much. The upper, because you can see the constraint. The constraint is a constraint which is less. A constraint in this case, which is fixing us on this area towards 0, less. And remember, for linear programming, we always shade off the unwanted area. So the unwanted area is this area like that. This is the unwanted area. So that is constraint number 1. Always shade the unwanted area. And then, ladies and gentlemen, come straight away here and give us constraint number 2. For constraint number 2, I'm not interested in the zeros up there. I'm interested in the x2, which is 40. X2 is 40 there. And then I have x1, which is what here, 16. X1 is 16 there. So come and join the 2 very well, like that. This is constraint number 2. Which side of this constraint am I going to shade the unwanted? To know which side is unwanted, look at this inequality. It's less or equal. So if it's less or equal, then the upper side is what is unwanted. So I'll come and shade this like that. I will come and shade this like that. Ladies and gentlemen, of course, we know that our axes are permanently shaded on the negatives here, permanently, so that now we have a feasible area. And this feasible area, this is A, this is B, this is C, this is D. You mark the corners like that. You mark the corners like that. So after you mark the corners like that, using corner point method, I would want you great students of ours to give us the coordinates of the corners. So give us the coordinates of the corners. So we have here x1, we have there x2 like that. X1 and x2 like that. So come here straight away, give us these coordinates. Give us the coordinates. I would want somebody there in the comments who is able to see the coordinates of corner A in this particular feasible region. The coordinates of corner A. Is there somebody who is able to see the coordinates of corner A? The coordinates of corner A. Yeah, very good. I can see from Fidelis, even Juliet, even Edward, 0, 0. Thank you very much. So A, we have 0x1 and 0x2 like that. How about corner B? What is the value of x1 at corner B? At corner B, x1 at corner B, x1 at corner B, 0. X1 at corner B here is 0. How about x2 at corner B? X2 at corner B, somebody is able to hear me. X2 at corner B is 20. Thank you very much. Go to C. C in this case here, this is a tricky one. I don't know whether these students of mine who are able to buy this powerful machine, FX 570, have they been able to buy this 570? Or who has a very good graph there? Who has a very good graph there? Who can estimate, do exact projections for us, exact readings for us, for see what is the value of x1. Don't go by mine. Mine, I don't have a ruled page. Don't go by mine. Please work with yours. Work with yours. Work with yours. Or thereabout. Juliet 11, 12. Ekabala says 11, 11 or thereabout. We have Zach. Zach is saying 11, 12. Milka is 11.5, 11, 12. There is another calculator of mine. I don't know whether I can. Okay. Now, ladies and gentlemen, many students are saying that x1 is supposed to be 11 And then x2 is supposed to be what here? 12, 12, 12. What we could do is to solve. You can just try solving these two equations simultaneously. If you can, just come and draw the two equations, or rather solve the two equations simultaneously. Solve the two equations simultaneously. Unfortunately, I also don't have my calculator today, so we have to go the longer way for us to be just so sure. The two equations which are meeting to make up C is 4x1 plus 5x2 equals 100. And then we have 5x1 plus 2x2 equals 80. So if I want to eliminate, ladies and gentlemen, x1, I'll have to interchange the coefficients. Come and multiply this with 5, come and multiply this with 4. Right? So this multiplied with 5 will give me what here, somebody? We interchange them. So we have here 20x1 plus 25x2 equals 500. And then we have here the second one will be 20x1 plus 8x2 equals 320. So then come and subtract the two to eliminate these. So we'll have 500 minus 320. We'll have 500 minus 320 equals, divide this by, open brackets, this and this, 25 minus 8. So I'm getting x2 is 11. x2 is the one that is 11. x2 is the one that is 11. x2 is the one that is 11. How about x1? Having gotten in this case, ladies and gentlemen, the value of x2, I'll very easily get the value of x1 from any of the two equations. Like I know x1 now will be 100 minus 5 times 11, because I'm taking this to the other side. I'm taking this to the other side, right? Whatever I get, I say divide by 4, which will end up giving me what here? 11 as well. Let me try again this. So it is 100 minus 5 times 11, right? Divided by 4. This calculator has a problem. Mode. It's on my calculator. Mode, fix 9. I'm getting 11 points. Let me repeat the whole of this. So we have 500 minus 320 equals, divide this by minus 8. This calculator has a problem. I don't know. Just give me 2 minutes. I get my calculator. Give me 2 minutes. I get my calculator. go to any of these two equations. So in this case here, from equation one, what are we able to get here from equation one? If you go to equation one, ladies and gentlemen, equation one over here is 4x1 plus 5x2 that we know its value, which is 10.59. 10.59 should be equal to 100, meaning that 4x1 will be equal to 100 minus 5 times 10.59. So we have here 100 minus 5 times 10.59, which gives me 47. So I want this to be divided by 4, so that I can be left with x alone. So then this will give me 11 point what here? 11.7 what here? 6. So if you get 12 versus say 11, that is still okay. That is okay because, you know, for graph, you cannot very easily really be able to do what here to get the exact decimals like that. So that is okay. Go to corner D. For corner D, could you kindly give me the coordinates? Corner D, you don't need a calculator. Corner D is right at the periphery. Corner D, I simply want you to read. Corner D, what do we have there? Somebody at corner D. Corner D, what do we have here at corner D? Corner D, what is the value of x1 and what is the value of x2? Corner D, I've been told here by somebody here, there is a student here called Edward. He's told me that x1 is 16, right? And of course, x2 will be 0. So ladies and gentlemen, for each corner, come and they give us the z. Give us the total contribution. How do we get the z? The equation is given here. Z is 10, x1 plus, we have here 5x2. So for each of the corners, ladies and gentlemen, give us the z value. Give us the z value. So we start with the first corner where x1 is 0 and x2 is 0. So we have z equals 10 times 0 plus 5 times 0. Meaning mathematically that z will be equal to what here, somebody? Z will be 0. How about at corner B? Can somebody give me the value of z? Corner B. At corner B, can somebody give me the value of z? At corner B, can someone give me the value of z? At corner B, can someone give me the value of z? I'm being given a figure of 100 by Fidelis and Juliet. They are telling me that at corner B, z will be 10 times 0 plus 5 times 20. So 100, you're right. How about corner C? Corner C, I have my figure. It will be 10 times 11.76 plus, we have 5 times 10.59. Is there somebody who is getting a figure there? For corner C, 170.55. 170.55. And then now we have corner D, which of course will give me 100 and what here? 160. 160. Now, ladies and gentlemen, with whatever that we have there, what recommendation are you going to give? What recommendation are you going to give? What recommendation are you going to give? Remember, our objective was to maximize Z. So we shall recommend that they work with that corner which has the highest Z value, which has the highest contribution. In that regard, the highest Z here is this one. 170.55 is the highest Z. And therefore, this is the optimal contribution. So you're saying that the optimal Z, what we are calling optimal contribution, equals 170.55. And if that is the case, then the optimal quantities are full colon x1 as per corner C now. X1 will be 11.76, and then x2 will be 10.59 as per corner C. But you see, ladies and gentlemen, this evening I never came here because of this method. This evening I came to show you how we solve this problem using a very simple method called the simplex model. So mention there for us simplex. So unless there is a question, mention there simplex, but please have these figures in your mind because we should be able to get the same figures using simplex method. We should be able to get the same figures using simplex method. So simplex is written like this: simplex, simplex method, simplex method, simplex method, simplex method. So right away, the first step under simplex is to formulate. So the first step is to formulate. Step number one, formulate. That is step number one. Fortunately, we had formulated our problem. Our objective function was to maximize it, which equals 10x1 plus 5x2 plus 5x2 plus 5x2. Then we have here subject to number one. The formulation already are done. Subject to number one, we have 4x1 plus 5x2 less or equal to 100. Number two, we have 5x1 plus 2x2 less or equal to 80. 80. Number three, we have x1 comma x2 greater or equal to 0. 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 That is the first step of simplex. Now, having done the first step of simplex, ladies and gentlemen, the next thing that I will do is to come here and standardize. You standardize. So standardize the formulation. We standardize the formulation. We standardize the formulation. Standardize the formulation. Standardize the formulation. Now, how do we standardize? In standardization, the Z equation has to be equal to 0. The first thing that you do when standardizing for Z, you have to bring all the Z values on this side. So here it was a positive, now it becomes negative. 10x1 minus 5x2. Z equation must always read equals to what here? 0. When you're standardizing, you standardize. You put this in the structure of simplex. You standardize. Now, ladies and gentlemen, having captured the standard formulation of the Z, now you go to the constraints. The constraints, I would want to take care of the inequality. I want to get rid of the inequality. This inequality, and I can see the inequality is the less than. So when it is less than, what you do in the standardized subject to constraints, what you will do is to come and write here 4x1 plus 5x2 plus slack 1 equals 100. Just write like that first. Write like that, I'll be able to explain later. Number two, you'll come and talk of 5x1 plus 2x2 plus second slack 2. Then we should be able to get these being equal to what here? Being equal to 80. Now, ladies and gentlemen, I would want you to listen and listen to me very well. If you're given a number like 6, and then someone tells you that 6 is less than what? 10. And then, if you are in a situation where you would want to get rid of this less, you want to get rid of the inequality, what you'll do is to make an adjustment on the left-hand side. You make an adjustment on the left-hand side. So on the left-hand side, you'll have to ask yourself, what do I add on the left-hand side to have the two sides being equal? So what do we normally add on the left-hand side? Like now in this case here, it is the difference. The difference between the two is 4. So I come on top of 6 plus 4 equals what here? 10. Here we are able to do that because these are, but if you look at our case, now we have x. We don't know what x is. And that is why we are introducing what we are calling this S. This S here represents the slack. If you can remember from network analysis, slack is spare. Slack is spare. What in this case is a spare on the other side for us to have the two sides being equal. being equal. If, for example, ladies and gentlemen, I had this kind of a sign. If, for example, you have here x2 is greater than, say, 10. On the left-hand side here, as we shall be seeing later, I would have come here and subtracted what we call the surplus. You subtract the surplus, but for now, let us not go there. For now, we are talking of the standardization. Standardization, two things. Ladies and gentlemen, standardization. And ensure that the z, parameter z, you give z an equation, which at the end of the day will be equated to 0. So meaning that you have to transfer these things to the other side. So it will be z minus 10x1 minus 5x2 should be equal to 0. Subject to number 1, and then we have number 2 like that. We don't bring the non-negativity here. We don't bring the non-negativity at all in the standardized formulation. Any question, ladies and gentlemen, up to there? Because the moment you understand the two, you know, you have understood the entire simplex. Any question? Any question? Any question? Please feel very free to ask questions. Feel very, very free to ask questions. Feel free to ask questions. Now, ladies and gentlemen, step number 3, after you have standardized, the third step after standardization, the third step after standardization, the third step, come and give us, ladies and gentlemen, the third step, come and give us number 3, the initial simplex table. The initial simplex table. The initial simplex table. The initial simplex table. You give us the initial simplex table. Initially, we assume that we have not yet started producing our x1, x2 products. So initially, we are assuming that our x1 equals 0 and our x2 as well equals what here? 0 there, initially. And then, ladies and gentlemen, we'll have what we call the bases here. Each of the variables will have to be provided for in our table. Initially, we had x1 and x2, but for purpose of standardization, we introduced slacks. So we have slack 1, we have slack 2. Slack 1, slack 2 like that. And then, of course, we'll be having what we shall be calling right-hand side values. Right-hand side values. Right-hand side values. Now, I would want you to listen and listen to me very well. Listen and listen to me very well. Caro is asking, where can't it be 10x1 plus 5x2, 10x1 plus 5x2, or the z, how the z was, the z equation according to Caro, the z was equal to 10x1 plus 5x2 plus 5x2. So Caro is asking, why can't we have here 10x1 plus 5x2 equals what here? 0. Caro, that can't be the case because you will basically be telling us that z equals 0, and z is not 0. Z is not 0. If you do it your way, Caro, you'll be telling us that 10x1 plus 5x2 equals 0, meaning that z is 0. Our contribution can't be 0. And according to the rule, they simply want us to standardize this by bringing all these other terms here. So how do we bring these other terms on the other side? You will simply come and change their signs. So you will have z minus 10x1 minus 5x2 equals what? Equals 0 like that. You'll be able to see the essence of us transferring these as we get along. But for now, know that it will not be proper for us to have our z being equal to 0. Now, ladies and gentlemen, in our initial simplex table, we normally start with the constraints. And remember, for these constraints, ladies and gentlemen, what have we said? We've said that at the moment, x1 and x2 parameters are 0. So constraints x1 and x2, they are 0. So then what do we have here? Don't put these here. We are starting with x1 and x2 constraints, which are what here? 0. So if x1 and x2 are 0 at the moment, Then on the solution area, feasible area, we shall have the slack. So for constraint number one, I will have the slack. So I'll say slack one has got what right-hand side figure here. Slack one has 100. Slack one equals 100. When you go to constraint number two, the same. Because you are starting at this particular point, ladies and gentlemen, here, this particular point where x1 and x2 are 0. So in constraint 2, we shall have this term disappearing, and then we'll have here s2 being equal to the right-hand side value of what here? 80, like that. Now, ladies and gentlemen, listen to me very well. After you have transferred these particular parameters the way you have done, come and fill this table inside here with coefficients. So we start with constraint 1 coefficients. Constraint 1 is here. The coefficient of x1, the number that comes before x1 here is 4. The number that comes before x2 here is 5. The number that comes before s1 in constraint 1 is 1. There's an implied 1 there. So write 1. And then, of course, s2 is nowhere here. S2 under constraint number 1, because it's not there, you write 0. Write 0 like that. Write 0 like that. Now, if you're following, my friends, could you kindly try to insert the constraint, or rather the coefficients here for constraint 2? Try to insert the coefficients of constraint number 2 there. Just try. Don't worry. These are very simple things. You'll be able to like it. Just try and write for me there. Just try. For constraint number 2, ladies and gentlemen, what we have here, I like Simplex a lot, because at the end of the day, and that is why the person who discovered this model called it Simplex, it's a simple thing. Is there somebody who has an answer for me there? 5201. 5201. Is it only 1 0 or many of them?
6.
Like 6 of them. Thank you very much. So for constraint number 2, the coefficients here are x1 we have 5, x2 we have 2, s1 is not here, s2 we have what here in front of it, we have a 1 like that. And then lastly, you come and align there, and then you put z for us there. Again, try giving you the coefficients of the z equation in this, of the z equation, put the coefficients there. The 1 for x1, the 1 for x2, etc. The first one is negative 10, isn't it? The second one? Negative 5. The third one? 0, 0, because S1 and S2 are not in the Z equation. And for us to show that they are not in the Z equation, we give them a technical knockout. We give them a technical knockout. We give them a technical knockout by giving zeros like that. So any question up to there, ladies and gentlemen, please ask questions, don't fear anything, because the moment I understand this, I'll never have a problem with graphical, I'll never have a problem with computer printout, interpretation. Very good. Now, ladies and gentlemen, having done that, the next step will be for us to, number 4, assess the table above. The table above for optimality. Assess the table above for optimality. Assess the table above for optimality. The question is, how should I do that? We check on the Z values. We check on the Z values and the table can be said, can only be said to be optimal, can only be said to be optimal if all the Z values, are positive. If all the Z values are positive. The table can only be said to be optimal if all the Z values are positive. If all the Z values are positive. So assess the table above for optimality. How do we do that? We check on the Z values. And the table can only be said to be optimal if all the Z values are positive. If all the Z values are positive. If all the Z values are positive. So the question that I'm putting across to you, look at the Z values that we have. Are they positive, all of them? Are they positive, all of them? Are they positive, all of them, somebody? Are they positive, all of them? No, they are not positive. They are not positive, all of them. So we say the table above is not optimal. We're writing there, the table above is not optimal since it has negative, Z values. The table above is not optimal since it has negative Z values. Since it has negative Z values. Now let me ask you a question. If a table fails optimality assessment, what should we do? Cry? So we have to draw another table. If a table fails optimality, we have to draw another table. So in this case here, construct another table here. So step number 5, construct another table. Another table. We construct another table because the earlier table has failed optimality assessment. The question is how? How? So ladies and gentlemen, how? Number 1, A, we identify the pivot column. We identify the pivot column. Now this pivot column is the column, i.e. the column with the highest negative Z value. Our negative highest is quite literal. We're looking at highest negative. In this particular case, our highest negative will be negative 10. So you mark this. When you mark this, ladies and gentlemen, it means that this is our pivot column. You circle it like that. So this is the pivot column. Now, ladies and gentlemen, I would want you to understand this very well. We've been able to identify the pivot column, which is the column with the highest negative Z value. Step number 2, for us to be able to draw another table, is to determine the ratios. You determine the ratios. Ratios between RHS and the pivot column elements. So you determine the ratios between RHS and the pivot column element. So come and create a column here for our ratios, where our ratios will be RHS divided by pivot column elements. You take RHS divided by pivot column elements. Right-hand side values divided by pivot column elements. So please divide this for us. So we have 100 divided by 4. 100 divided by 4, that gives me what here, somebody? 25. And then we have 80 divided by 5. 80 divided by 5 gives me what figure, somebody here? 80 divided by 5. 80 divided by 5. I'm getting 16. Here. That is step B for constructing the next table. Ladies and gentlemen, from there, C, identify the pivot. Identify the pivot row. You identify the pivot row. Basically, this is the row with the lowest ratio. Row with the lowest ratio. the lowest ratio, the row with the lowest ratio. So the lowest ratio is this. When you compare the two, the lowest ratio is this with 16. So please come and mark it like that. You mark it like that. You mark it like that. So ladies and gentlemen, this is what we are calling our pivot row. Pivot row. We have our pivot row like that. We have our pivot row. Our pivot row. Identify the pivot column, do the ratios, identify the pivot row, which is the row with the lowest what here? Ratio. With the lowest ratio. Thank you very much. Now let us draw this table together now. Let's draw this table together. It's quite interesting, quite easy, quite easy, quite easy. So we have our new table here. We'll have the same headings, basis. We have X1, we have X2, we have S1, S2, right-hand side, and then we have the ratios. Now, ladies and gentlemen, I would want you to see something small here, very small, on the basic variables, on the basic variables, on the basic variables. You see, this pivot column variable, the pivot column variable must always join our bases. Actually, the very best which you should do, you should always extend this column to touch this. Yeah, so we have a big thing there. The same case here with the row. So we have a big thing there, right? So I would want you to see something here, that this pivot element variable, the pivot column element must always replace the pivot row variable. And the exchange can only be one at a time. So here we are seeing that the pivot row element, the pivot row variable must disappear, always. The pivot row variable must always disappear. And its position will be taken by the pivot column variable, meaning that this one will remain. So we'll have here S1, but when I come here, I'm able to see the pivot. This has to go. Where it goes, we don't want to know where it goes to, but we know that it has to be replaced by the pivot variable. The pivot variable comes here always. So now we have there, instead of S2, we talk of what somewhere there, X1, sorry, X1 like that. No problem. So come here, put like that. Slowly. We shall have also our Z there. We shall have our Z there. Now, ladies and gentlemen, I would want you to listen and listen to me very well. Listen and listen to me very well. Yeah, I can see a question in the pivot column. You said the highest value of Z. Why did you pick -10 instead of negative what here? 5. Now, good question. And I told you that we should pick them literally. I understand what the gentleman is saying. You see, we have got two values of Z. We have Z equals -10, and then we have Z equals negative what? 5. Right? Now, ladies and gentlemen, these are opportunity. Where do we stand to lose most? The question is, where do we stand to lose most? Where we stand to lose most is when we lose what here? 10, instead of losing what? 5. And I told you, literally, we shall be taking the highest negative. So the highest negative here, in this particular case, will be what? A -10. Don't give it a mathematical interpretation. Where we stand to lose most, that is like our penalty. Where we stand to lose most is like our penalty. We always work with the highest mother tongue way. Highest negative. Highest negative. Highest negative. I hope I've answered your question. Now come here. Now, ladies and gentlemen, I would want you to listen and listen to me very well. When it comes to transferring this table here, normally we start by transferring the pivot row. We start by transferring the pivot row. But after making an adjustment, what is the adjustment? That this particular value that you are seeing here, this particular value that you are seeing here, which is called the pivot element, must always be equal to 1. Listen and listen to me very carefully. Now I'm in the process of transferring my figures to this particular new table. And the very first row, we normally use what we call row reduction. The very first row that we shall transfer to this particular new table is the pivot row. But after ensuring that the pivot element is equal to what? Is equal to 1. So how do we ensure that the pivot element, the one that is at the intersection is 1? You divide all the figures that we have in the pivot row by 5. So come and pick, you see the pivot element here is 5. So this pivot row standardized basically will be equal to the old pivot row. You divide each one of the elements there by 5. So ladies and gentlemen, if we do that, what will we have here? Remember, this is row 2. So they can only come to row 2 here. So we have 5 divided by 5, giving me 1. Then we have 2 divided by 5. 2 divided by, I'm going to divide all elements by 5. Here I'm getting 0.4. This will be 0. This will be 1 divided by 5. Maybe you know the answer easily. Just divide using a calculator. 0.2. And then we have 80, ladies and gentlemen, divided by what here? Divided by 5. So we have 80 there, divided by 5, giving me what figure, somebody here? 16. I'm going to repeat this once more. What have we said? Identify the pivot column. Pivot column will give birth to ratios. Those ratios will help us get the pivot row. After I get the pivot row, when I'm transferring the pivot row to this new table, I must ensure that the pivot element is always what? Is always 1. The pivot element is that element which happens to be at the intersection of the pivot row and the pivot column. That element is a yardstick. Always ensure, ladies and gentlemen, that that element is 1. If, for example, here I had 10, then I would have divided everything in the pivot row by 10. But now here we happen to be having our pivot element being 5, so I have to divide this by 5 throughout. And I'll be able to explain. Like if you look at this S1, you see S1, S1. What do we have? 1 there. All the others are what, you see? That is what I want to do. I want to have X1 and X1 first of all being 1. And then all the others will be what? Will be Z? Will be 0. Will be 0. Now leave alone the ratios. This particular first row that you have brought here is called a reference row. It's called a reference row. It is the row that will give birth to all the other rows that we are missing here. It is a row which you're going to make use of and get all these other figures that you are missing there. Now, ladies and gentlemen, listen and listen to me very well. I know this is a little bit confusing, especially if you are seeing it for the very first time, but it is something that you're going to like because it is always there in our exams. And again, it forms a very good base for interpretation of what here computer printouts of LP problems. So we must understand, we don't have really much of a choice here. We just have to understand this. So we have been able to transfer the pivot row here, and we were able to do some adjustment. Now we transfer the other rows as well. Let's transfer the other rows. 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 So we start with row 1. So I want us to transfer row 1 here. We transfer row 1. So I want us to transfer row 1. So how do we transfer row 1? So we have here row 1. So working for row 1. And working for row 1. So row 1, I'll write here the old row 1. Old row 1, I'm able to see it there. The old row 1 is 4, 5, 1, 0, 100. Leave out the ratios. 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 Very good. Very good. Now, ladies and gentlemen, here we are. You take the old row 1, and then we'll come and talk about, ladies and gentlemen, you will come and talk about something here. Minus. If you understand that this, you have understood the entire thing. Minus. We'll come and pick in row number 1. Row number 1, just like I told you, Here we had 1, 0, 0. Here we have 1, 0, 0. If you look at whatever we have here is 1, we would want to kill all these other figures to 0, 0. So I would want this figure which is here, which is 4, to be 0. To be 0. So how do I shoot it down? To shoot it down, I'll say minus, it's called row reduction, minus, I'll pick something from there times the reference. And this something that I will be picking from row number 1. There's something that I'll be picking from row number 1 is the figure that I would want to drive to 0. This figure of 4. So I'll come and say 4 times the reference. So 4 times the reference which we have here. So it will be 4 times 1, like that, like that, like that. So the first one is 4 times 1. 4 times 1 gives us 4. You are going to multiply this reference with the 4 throughout. So 4 times 0.4. So we have here 4 times 0.4, giving me 1.6. And then we have 4 times 0, giving me 0 there. And then we have 4 times 0.2. It's good always to use your calculator. 4 times 0.2 gives me 0.8. And then lastly, we have 4 times 16. 4 times 16, that will give me 64. So you subtract. So you subtract, what are we going to get here? We have 0. We have 5 minus 1.6 there, giving us 3.4. Then we have 1 here. Then I have negative 0.8. Then I have 30 what here? 36. So this becomes new row 1. New row 1. So for row 1, these are the figures you will bring here. We have 0, 3.4, we have 1, we have minus 0.8, then we have 36 there. 36. So I want you guys to do me a favor. I know this is quite a little bit difficult, a little bit disturbing, but I'm so sure all of us will be very comfortable before the class ends. I want you guys to do me a favor. Could you kindly try working out the Z row for us? Just try working out the Z row for us. So we have, yes,
from Milka.
Milka, yes.
Where is 4 coming? Please repeat where 4 is coming from.
4. Where is this 4 coming from? Remember, we said like now from here, we have 1, 0, 0. I would want to have the same here. You see, 1, 0, 0. So I would want to shoot down the figure that is here in my original table. So in my original table, the figure that I would want to, basically all these pivot elements, listen to me, the pivot column elements are going to be shot down to 0. And how do we shoot them down to 0? Like for first row, I'll use what here? I'll use 4. Milka, that is where I got 4 from. Because I would want in row number 1 to have 0 here. And you can see after I kept 4, 0 there, what do I have here? 0 like that. I don't know whether I've been able to answer her. Yes, Milka, have you really seen where I got the 4 from? Milka, I'm waiting for you. Milka, perhaps she's trying to understand. Yes? We are supposed to multiply. We are supposed to multiply. Now, for the student who is saying, I repeat, if you could allow me, I'll repeat the same concept using the Z row. Using the Z row. So please write for us there, Z row. Z row. So we have here the Z row. 2 things. Number 1, we have the old Z row. So are we able to see the old Z row? So the old Z row. The old Z row which we have here, this old Z row is minus 10, minus 5, we have 0 and then 0. So I'm going to say minus, a big minus there, something times reference. Especially for the student who say there who asked me to repeat. Could you kindly tell me what you think am I going to pick? From the Z row, I multiply with the reference. From the Z row. From the Z row. What item am I going to pick from there? I multiply it with the reference. 5, eh? He says 5. Good trial, but you've missed it a little bit. You see, this is the Z row down here. You pick a figure from the Z row. You pick a figure from, not from any other row. You pick a figure from the row you're working on. Is there anybody who is able to see that figure which I should pick?
-10.
They are saying negative 10. Only one student? Juliet? Alex? Thank you very much. So the Z row under the pivot column, the figure that I want to shoot down is this minus 10. So I'll come and say minus 10 times the reference. So minus 10 times the reference figures here. Minus 10 times the reference figures. So we have minus 10 times 1, giving us minus 10. And then we have, of course, minus 10 times 0.4, giving us minus what here? Minus 4. We have 0 here. It's minus 10 multiplied by each one here. So minus 10 times 0.2 gives us what here? Gives us 2. Gives us 2 like that. Gives us 2. Right? And then you can see that for the Z row, I'm not interested in the right-hand side value of the Z row. We are not interested with the right-hand side value. Right-hand side value, we are not interested with it at all. We are not interested with it at all. So please come and subtract for us. Kindly subtract this for us. What are we going to get somebody here? So the first one here will be what here? 0, right? 0. And then we have what here, somebody? We have minus 5 minus 4. Minus 5, this minus 4, which will end up giving us what figure, somebody here? This will give us minus 1, because it's minus 5 minus 4. Minus 5 plus 4. Plus 4, which will end up giving us minus 1. And then we have this is 0. Sorry, this is supposed to be minus 2, because of minus 10 times this. It's supposed to be minus 2. So when you take 0 minus 2, that gives us what here? 2. So this is a new Z. The new Z row. New Z row. So the new Z row, what do I have here? Somebody, I have 0, minus 1, 0, and then what, somebody there? 2 like that. So I know you may not have understood exactly what I've done, but now here I have a new table with us. Every new table, complete table that you have, you must always assess it for optimality. Is this table the very best table that we have? Is it the very best table? Can somebody try answering that? Is this table the final table? Is it the best table? No. Why do you think has it failed the optimality assessment? We still have a negative Z value. We still have a negative Z value. And if we have a negative Z value, if I have a, so you mentioned there that the above table is not optimal. Mentioned there, the above table is not optimal. The above table is not optimal. The above table is not optimal. The above table is not optimal since we have a negative Z value. Since we have a negative Z value. Since we have a negative Z value. And if it's not optimal, we must construct another table. So come here and construct another table for us. Another table, quite tiresome, but very good and very many marks in our exams. So construct another table for us. So identify the pivot. Identify the pivot column. Identify the pivot column. Can someone tell me, in this particular case, which column will be our pivot column? The one that has got the highest negative. The one that has got the highest negative. One that has the highest negative Z value. Highest negative Z value. So the highest negative Z value, we have this one. Is there somebody who has an answer? No. So this should be my pivot column. Pivot column. So this is the pivot column. Now, ladies and gentlemen, having gotten the pivot column, what do you think would be the next thing for us to do? What are we going to do after getting the pivot column? Okay. Sorry for that. We calculate the ratios. So come and calculate the ratios for us. So calculate the ratios for us. But now the question is, how do we get these ratios? How do we get the ratios? Somebody talk to us. How do we get the ratios? How do we get the ratios? You take RHS, right-hand side values, divided by pivot column elements. So you take the figures that we have here, like now we have here 36 divided by 3.4. Give us a figure. We have 36 divided by 3.4, give us a figure. What are we able to see here? 10.59, right? And then we have 16 divided by 0.4, giving us 40. 16 divided by 0.4, giving us 40. 16 divided by 0.4, giving us 40. Giving us 40. Giving us 40. Giving us 40. Are those figures correct? Are those figures correct? They're saying yes, right?
Yes.
Thank you very much. So remember, I'm guided by yourselves. I am guided by yourselves. I am being guided by yourselves, ladies and gentlemen. I've been able to get the ratios. So step number 2, ascertain the ratios. Ascertain ratios. And of course, identify the least ratio. Identify the least ratio. So which ratio happens to be the least here? Somebody, the one of 10.59. So this 10.59 is the lowest ratio, this one here. And if it is the lowest ratio, we know straight away pivot column, pivot row, I mean. Pivot row, the one with the least ratio. The one with the least ratio. The one with the least ratio. So I'll come and circle it kabisa kabisa. This one. You circle it kabisa kabisa. Very good. Very good. So this is the one that I'll call the pivot row. The pivot row. Pivot row. Now, ladies and gentlemen, having gotten the pivot row, what do you think will be the next step for us? Somebody advise us. Somebody advise us. What do you think will be the next thing for us? We draw the table. Thank you very much. Come and draw the table here. Draw the table here. I told you by the end of this class, all of us will be very happy having mastered this thing that so many students fear for nothing. You will be able to see nothing. So we have here basis x1, x2, s1, s2, right hand side. So I would want to see whether there is any student who will be able to tell me the basis variables that I'm going to have inside here. What basis variables am I going to have? Somebody, basis variables. They're called basis variables. Basis variables. Basis variables. What basis variables am I going to have? X2. Thank you very much. That student has been able to know that always the pivot row variable has to disappear. It goes. In its place, we shall have the pivot column variable coming. So you are right. So we have here x2. And then, of course, we can only have these variables changing from the basis one at a time. If s1 has disappeared, all the others remain. So we have here x1, and then we have what here? Z like that. Great. Any question? Thank you very much. You are still the ones guiding me. I've been able to come up with my skeleton. I've been able to come up with my skeleton like that. Then what do you think will be the next thing to be done? What do you think shall we do? Waiting to hear from you, my great students. What shall we do? Very good. We are just, so in short, what that student is telling us is that we shall start by transferring this pivot row. Pivot means what here? Something that is a fulcrum, an important thing. Now that we're talking about rows, we shall start by transferring the pivot row here. The pivot row that we have, ladies and gentlemen, is in row number 1. And is also going to be in row number 1 there. But as the student has told us, ensure that the pivot element is the one that is at the middle here. The one that is at the intersection of the pivot row and the pivot, this one here is what we're calling the pivot element. And that student has been able to nail it down very well. She's telling us that we ensure that the pivot element is what here is 1. But now it is not 1. It is 3.4. So we must divide all the pivot row elements with what here? 3.4 across the board. So the first one will be 0 divided by this, which gives me 0. The second one will be 3.4 divided by 3.4, which gives me 1. The third one will be 1 divided by 3.4, 2 decimal places. This will give me 0.29. Then we have minus 0.8 divided by 3.4, which will give me minus 2.4, minus 0.24, I mean. And then lastly, we have 36 divided by 3.4, giving me 10.59, like that. Now, from there, ladies and gentlemen, of course, I know that this first row that I bring here will be called the reference row, will be the reference row. The row that you bring there will be called the reference row, the reference row. So I would want to see, ladies and gentlemen, as we prepare to finish this class, is there any student who can be able to develop the second row for us? Just try the second row. Just try the second row. The second row, just try drawing the second row for us, kindly. Or rather getting the row 2 figures, kindly. So is there somebody who has been able to do our row 2, row 2 figures? Somebody give us the figures there. Just type them there. Now I can see Juliet and Melissa have finished. Great, and I hope all the other students are almost there. This thing is not a hard thing. It's just something that you have to understand. So like now here, I know that my objective for the pivot column is to have this one here being 1. And then all the others are what? Yes, somebody has 0. So I'll come and write here, second row. I'm a row 2. So second row, working for row 2, which is this one here, row 2. So I will start by saying the old row 2. So the old row 2, what do we have? Old row 2. The old row 2, we have here 1.4, 0, 0.2, and then we have 16. Leave alone the ratios. Leave alone the ratios. Leave alone the ratios. Leave alone the ratios. Thank you very much. Now from there, I'll come and say minus a big minus. Something here times the reference. So this something that you're talking about, ladies and gentlemen, is which one here now? When I come to row 2, there's something that I'm talking about here. It's this in row 2, the one that is in the pivot column, the one that we want to drive down to 0. So it is 0.4. So I'll come and say 0.4 times the reference. The reference for our table there, the new table we are constructing, we have its reference. So we have here 0.4 times the reference. So 0.4 times the first figure here is 0. So we have 0 there. Then we have 0.4 times 1, which gives us 0.4. And then we have 0.4 times 0.29, which gives us a bad figure here, 0.116 or 0.12 to be consistent, 2 decimal places. And then we have the next one, minus 0.24 times 0.4 times 0.4, which gives us minus 0.09, that can be 0.1, minus 0.1. And then lastly, we have 10.59 times 0.4, which will end up giving us 4.24. So we have here 4.24 like that. So please go ahead and subtract for us. So you're subtracting this and this gives me 1. This and this all gives me 0. This gives me minus 0.12. This gives me 0.2 minus 0.1, which gives me approximately 0.3. And then we have 16 minus 4.24, which gives me 11.76. 11.76. So this is what I will bring here. This is what I will bring here. So we have 1, 0, minus 0.12, and then 0.3, and then lastly there 11.76. Now could you kindly do for me the working now for the Z row yourselves? The last one. Just do the working for the Z row. Do the working for the Z row. Do the workings for the Z row. Do the workings for the Z row. What do we have there? Workings for the Z row. So here I should have written new row 2. Here I should have written new row 2. New row 2. New row 2. So Z row, how do we do it? Old Z row, and then subtract something, new Z row. Let's see. Let's see. Let's see. Let's see what we have there. Let's see. Let's see what we have there for the Z row. For Milka, are we dividing the figures by 3.4? The ones that we divided by 3.4 are these one here. Everything was divided by 3.4, and then we got what we call the reference row. Reference row. Perhaps when I repeat again, Milka will be able to pick it. Like today, I've lost you completely. You must have come in maybe late. Don't worry, we shall overcome. What perhaps I could do is to repeat this video, replay the video after this session. I can replay the video. If you have that energy of staying from 11 to 1, you watch. I'm waiting for the answers for the Z row. Just try, give it your best. Old Z row minus, just give it your best. Juliet has already gotten figures. Melissa, getting the same figures. Someone else? I'm waiting for a third person for us to conclude. From Juliet, the table is optimal for Alex. Alex. Now, ladies and gentlemen, let's do this old Z row together. The old we start with. We adjust the old Z row. So we have here Z row. So Z row, we start with the old Z row. So old Z row, what do we have here somewhere? Which is 0, minus 1, then 0, 2. Then I'll come and say minus, a big minus, because it's called row reduction. We'll say something there times the reference row. So there's something in the Z row to be eliminated. I can even see it. There's something to be eliminated in the Z row has been marked for us. It is within this pivot row, the pivot column, I mean. So it is this minus 1. The one that I want to be to eliminate is, so on top of minus 1 times the reference. So minus 1 times the reference, my reference is here. So then what do we have? Minus 1 times that gives me, the first one will give me 0. Minus 1 times 1 there gives me minus 1. Then we have minus 1 times minus 10.29 gives us minus 0.29. And then we have minus 1 times that, which gives us 0.24. For Z row, we are not interested in the right-hand side values. So come and subtract for us. When you subtract for us, what do we have? We have 0 here. Minus 1 minus minus 1, that gives me 0. This will give me 0.29 positive. And then we have 2 minus this. We have 2. The one on top there is 2. 2 minus 0.24. 2 minus 0.24. This is supposed to be 2 minus 0.24, yes. 2 minus 0.24, which gives us 1.76. So now this is my new Z. This is my new Z row. So this new Z row is the one that we bring here. Is the one that we bring here. So we have 0, 0, 0.29, 1.76. And of course, you can't see any negative there. So no negative Z values. And therefore, as Alex told us, the above table is optimal. 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 And if it is optimal, ladies and gentlemen, if it is optimal, ladies and gentlemen, what do? We go to the interpretation stage. If it's optimal, ladies and gentlemen, interpretation will come and look at this table very well and give them the optimal values. Give them the optimal values. So the optimal values, ladies and gentlemen, what do we have here for optimal values? We have x1 and x2. We read the right-hand side figures of the final table. So x1, you can see x1 is 11 point what here? 76. And then you can see x2, they want us to produce how many units here? Somebody 10.59, like that. So for optimality, the final table for you to know the quantities to produce, you read the basic variables, the right-hand side values of the basic variables. So x1 is 11.76 and x2 is 10.59. When we started, we drew a graph of this. Is there somebody who is able to remember that graph which we drew? And is there somebody who can give us the figure that we got using the graphical solution? Using the graphical, just make reference, using the graphical solution, what figures did we get using the graphical method? Using the graphical method, what figures did we get? The same figures. The same figures. Same figures. Same figures. Is that coming from only one student? From two. Who and who? Three. The same figures. At least these students have been able to move back to where we do the graph, and they've been able to confirm that in the graphical solution, we also provided the same OTR, the same figures, the same figures. Now, I'm so sure there are very many students who have really not followed this very well, and I can't blame them. I've taught this for so long. I know the first question that we do is never very friendly. But the moment we proceed, like in the next session, of course, I'll not do any question of simplex again. But what I'll do is to have this particular video replayed to all those students who have not been able to understand this very well, especially the ones who came in very late. So I don't know whether you could replay the video tonight or tomorrow at what time. And then, of course, there is this question that we did with you from our past papers using the graphical method. The other class, we solved another question, past paper question. I would expect you to go and draw that question up. You do it using the simplex method as our homework. So that when we come now in our next class, I'll be able to tell you what these figures mean. Shadow prices. What in this case here are our, they call reduced costs. And how do we take these particular parameters to our computer printout interpretations? Otherwise, ladies and gentlemen, I know it has been quite hard today for you. I'm so sorry for that, but we shall overcome.